All right, so in section 5.1, we're going to have fractions, okay? It's going to be one fraction only, and they're going to be putting polynomials on those fractions, meaning like maybe it's a trinomial on top and a binomial on the bottom. Maybe it's a monomial, meaning one term on top and a binomial on the bottom. And our job is going to be to try to factor everything that we can so that we can find matching parts. And when we find those matching parts, we're going to chop them up, okay? We're going to get rid of them. All right, so that's what we're going to basically start doing. All right, so here we go. First example. Again, these are all coming from your homework. So they're going to ask you just to simplify, okay? Simplify each expression. I'm just going to put simplify. So the first one, we'll just write it out the way they have it here. P squared plus 5p plus 6 over p plus 2. So our job is to try to simplify this as much as possible, chop out everything that matches, and then just write out our final answer in simplified form. So one common mistake, by the way, guys, and I just want to remind you guys of this because this should have been something you guys learned before, but maybe you forgot. You cannot cancel like this, okay? You can't say like, well, there's one p on the bottom, so I'm going to get rid of one here and one there. Okay, you can't do that. If you get rid of something, they all have to kind of share it. So they all should have had a p on top and they all should have had a p on the bottom in order to get rid of one of those p's. So you can't do that. Another thing you cannot do, which I see a lot of people do, is they say, well, 2 goes into 6 3 times. You can't do that either. Okay? When you cancel stuff out, you have to get rid of, I always tell people, things that are either in parentheses or things that are multiplying other things. So you'll kind of see it as we move on and do this stuff. But it's either going to be stuff that's in parenthesis form, so we're going to be looking for things that maybe have like a parenthesis x plus 2 and another parenthesis x plus 2. Or maybe in front of a parenthesis there'll be a 10, and in front of another one there'll be a 20, and you're like, okay, so 10 and 20 are multiplying, I can reduce those. So just kind of watch what I'm doing here just to kind of get an idea. But if some of this stuff kind of looks confusing to you, let me know. But yeah, please don't just cancel out anything that looks like they have stuff in common. Factor first, then cancel after. Okay, factor first, cancel after. So here we go. This is the way I recommend it for you guys. You're going to look at the top, then you're going to look at the bottom, okay? Look at the top, I see a trinomial. The way we get trinomials factored is by using the x method. So that's what I'm going to do. I'm going to move to the side real quick. I'm going to write this out. And again, you guys don't have to do it the way I do it. This is just the way I do it to make sure that I'm doing everything that has to be done. So here's the top part. I know my A is 1, my B is 5, and my C is 6. Okay? So I'm going to do the x method on this. So 1 times 6 is 6, and b goes on the bottom. Two numbers that multiply to 6 that add up to 5 are going to be 2 and 3. So a positive 2, a positive 3. Do I have to divide for this one? No, right? A is 1, so that means these are my answers. So this is going to be a p plus 2 and a p plus 3. So on my actual work, okay, on the actual work on the left side, because all the right side is going to be all my scratch work, I'm going to write p plus 2, p plus 3. Everything that has two terms, you're going to notice I'm going to start putting in parentheses, okay? Now, I'm going to look at the bottom portion on the black problem, okay, the original problem. You see the p plus 2 now, right here, all right? Can I factor p plus 2? I mean, it's two terms, p plus 2. Do they have anything in common? No, right? They don't have p and 2 don't have anything in common besides the 1, so that never counts. Is it a difference of two squares? I'll tell you right now, it's not for sure. I know for a fact it's not a difference of two squares. What's the number one clue that it's not a difference of two squares? Well, there's a 1 in the front, which is okay, but that doesn't give me the obvious, not a difference of two squares. Well, 2 is not a square, right? But I'm going to go even easier than that. Sorry? Well, none of the things are squared either, right? The p is not. Oh, is that what you meant by it's a 1? Ah, okay. So when you said a 1, I thought you meant that there's a 1 in front of the p. You meant p to the first. Yes, that's another obvious thing, right? Even more obvious, I'm adding. It's called a difference of two squares because I'm supposed to be doing a difference, right? Subtraction. And I'm not subtracting, I'm adding there, right? So yeah, all those things are good reasons. I'm not subtracting. P is not squared. There's no way to write 2 as a square, right? It's not a difference of two squares. It's a binomial with no common terms. That means I cannot factor it. So what I'm going to do is I'm just going to write it with the parenthesis around. Now, if you remember what I told you guys, put the two terms in parentheses and look for common things on top and on bottom. Notice what matches on top and on bottom. The p plus 2, that means I can get rid of it. Okay, so that's what we mean by chopping it, right? We're going to chop it out. What's left? P plus 3 over what?
1.
Over 1, but do I have to write it over 1? No. So here's my answer. Now, I know this wasn't like crazy difficult, but notice how they're giving us a fraction with expressions, polynomial expressions. It's going to be my job to ask myself the questions of, okay, on top, can it be factored? On the bottom, can that be factored? And if they give me two different fractions eventually, and we're going to add and subtract them, I got to do the same thing. The first fraction, can I factor the top? Can I factor the bottom? The second fraction, can I factor the top? Can I factor the bottom? And then I got to combine stuff. So that's where we're going to get to eventually, multiple fractions being put together to solve. But for now, just one fraction. Okay, so this is a homework problem, like I said. It's not like necessarily impossible to do, but you are going to have to factor. Okay, so let me put example 2 here. And let me look for something that looks a little different. We're going to simplify. Oops, no, let me not put that there. We're going to simplify 3k minus 9, thank you, over 2k squared minus 9k plus 9. Again, on the right side, I'm going to be doing all my scratch work, okay, all the stuff that I'm just trying to work out on the side. And then after that, I'll try doing all my main work under the actual problem. Okay, organization for me, I found out when I got into late into high school, that organization is really important when it comes to math and sciences. So, try to keep things organized. Do your scratch work on one side. Heck, do your scratch work on a separate sheet of paper if you want, right? To really keep it separate. But yeah, those are just things. Neatness to me was my biggest issue. So I've always told you guys, I used to hate math when I was in high school. The reason is because my homework basically looked like this. Like I did everything sideways and in like 2 or 3 lines, and like right here maybe 4 lines. That was like a total of 12 problems all done. I didn't know what the heck I was writing, right? I knew I was doing it, I could never go back and check. It was too confusing. So yeah, just try to be neat with this, especially with this stuff. So here we go. All right, let's start off this one. I look at a fraction, I see 2 polynomials, a binomial on top, a trinomial on the bottom. So let me start with the top. Can I factor 3k minus 9? Yeah. What can I factor?
Positive.
A positive 3. So this is a GCF problem, right? So I can take out a 3 and I get k minus 3. Now, can I factor anything out of k minus 3? Did it become a difference of 2 squares? Well, it's a difference, right? But is it 2 squares? No. So that means I'm done. All right? Anytime you factor, always look at whatever you have factored and ask yourself those questions again. Can I keep factoring? Right? So 3k minus 3 is exactly what I'm going to write down here. 3 times k minus 3 divided by, okay, now the next part. 2k squared minus 9k plus 9. Can I factor that? Well, I got to find out. Okay, so it's a trinomial. That means that a is equal to 2, b is equal to negative 9, and c is equal to positive 9. I'm going to do the x method here. 2 times 9, that's 18. And right here is a minus 9. Okay? Give me two numbers that multiply to 18 that add up to negative 9. Negative 6, negative 3. Thank you. 6, negative 3. And do I have to divide?
Yeah.
Yeah, right here we got a 2, right? So divide this by 2. Divide this by 2. The left side will become a negative 3. The right side, I can't simplify, so I'm going to keep it at negative 3 halves. So if you guys don't mind, I'm going to take a real quick little tiny shortcut here. I'm going to write k minus 3, which is not the shortcut. The shortcut's coming in the next part. I'm supposed to write k minus 3 halves. I'm going to write 2k minus 3, which is basically what's going to happen if I write k minus 3 halves. All right? So let me put that back over here. K minus 3, 2k minus 3. Is there anything I can chop right now?
The k minus 3.
All right, those match, right? Matches on top, matches on bottom. So let's get rid of that. All right. Right now, I'm going to show you a situation that I was talking about earlier. So right now, here's my answer. 3 over 2k minus 3. Now, sometimes people do this, okay? And this is what I'm saying. Don't do it, okay? They'll cancel that out. Now, that's wrong. Don't write it down. Don't write it down. The little green marks that I did right there, that's completely wrong. Don't do that. The reason why I put parentheses around my terms is to remind me personally that that stuff is stuck together like glue. The 2k minus 3 is stuck together like glue, like super glue, okay? Cannot break it apart. The only thing that can get rid of the 2k minus 3, or actually let me be more specific. The only thing that can get rid of the 2 or the k or the minus 3 is a whole nother 2k minus 3. Okay, it has to be the same exact thing. So notice the k minus 3s that I canceled out on top and on bottom, I only did that because they were matching pieces. So if they match, I can cancel them. But if just this 3 here and just this 3 there match, I can't cancel it that way. Okay? Now, it's a different story. I know, and I'm just, by the way, this is the answer, okay? But right now I'm just writing stuff to kind of give you some input on what you can and can't do. If there was a 3 right here, then yes, you can cancel that out. If there was a 3 in the front, okay, that can go away, but not when it's inside of a parenthesis, okay? So unless you have another matching binomial like that, then go ahead. But if you don't, then don't mess with them. Just leave them like that, okay? So there's that answer. Again, not that this is anything that's super confusing to do. You guys should hopefully feel comfortable with this. But that's why we went over GCF on Tuesday. We went over trinomial factoring with numbers not equal to 1 for A yesterday, right? And then on Monday, we did this type of factoring, right, where A is equal to 1. So all that stuff's going to be showing up, okay, from here on out. It's not going to go away, right? All right, here's example number 3. I noticed there's only one problem here, I think, that is a difference of 2 squares. So I'm not going to do it, but I'm going to tell you right now there is number 7, if you want to write it down on your notes. Number 7 will be a difference of 2 squares, okay? Actually, yeah. So that's the only one that's a difference of 2 squares. When you go through it and do the work, just remember one of those factors, you're going to have to do a difference of 2 squares. But I don't want to do it because it's the only one. So I want to do one more from your homework, and then maybe I'll do a difference of 2 squares, but that won't be on your homework. But here's one from your homework. 25n squared over 10n squared plus 15n. So this problem kind of emphasizes something I was just talking about. All right, so you look at the top. 25n squared. It's a monomial. Okay, monomial means you cannot use GCF on it because it's just one term, right? You can't use difference of two squares because it's just one term. You can't do trinomial because it's just one term. There's nothing you can do to factor the top because it's literally just one term, 25n squared. So that's it. Okay? So I'm not going to mess with the top. I will look at the bottom. 10n squared plus 15n. It is a binomial. Do I have a GCF here?
Yeah.
What is my GCF? 5n, right? 5n. So that means 10n squared divided by 5n will be 2n plus, and 15n divided by 5n will be 3. Now, just because I factored it once doesn't mean I'm just going to move on. I'm going to look at my binomial and I'm going to ask myself, does that have a GCF, 2n plus 3? Is there anything in common with 2n plus 3? No, right? Is it a difference of two squares, 2n plus 3? No, it's a plus, so it can't be a difference. And, well, we just said that there's no GCF, so we're done. So, all right, we're good. I'm going to write this out. Okay, the top, 25n squared, nothing happened there. The bottom, 5n times 2n plus 3. All right. Now, what you cannot do, so don't do this, what I'm about to show you. What you cannot do is say, oh, there's an n here, I'll cancel one out there. Don't do that. Because if it's inside of the parenthesis, the whole thing has to disappear. A 2n plus 3 has to disappear. Go ahead.
Couldn't 5n simplify to 25n squared?
Yes. Remember what I told you guys. If you have one term on top and another term on the bottom that's multiplying. So if there's a term that's multiplying a binomial or trinomial, you can reduce that. How many times does 5 go into 25? 5 times. So I'm going to put a 5 right here. And then n squared divided by that one n in the front. There'll be one left here, and this one will be gone. Okay? So, here's my answer. 5n, that's all that's left on the top. Okay, 5n to the first. On the bottom, the 5n got canceled out, so all that's left is 2n plus 3. Bless you. And again, do not do this. Don't cancel those n's out, okay? Don't do it. I know it, and I know I'm saying it a lot of times, but I bet you that there's going to be at least 3 people that do it by accident, okay? And then you're going to be like, oh, wait, I'm not supposed to do that. It's just because naturally you're like, oh, matching parts. Cancel them out, right? One of the most common answers I get for this problem when I do this, one of the most common wrong answers is I get this. Okay? I'll get 5 over 5 equals to 1. Why? Well, because if you cancel the n's, on top you just have a 5, and on the bottom you have 2 plus 3. Right? And 2 plus 3 is 5, so it's 5 over 5, which is 1. It makes sense, but it's not right. Okay? So yeah, don't cancel them out. Are we okay with this one? All right, let me show you one more. I'm kind of going a little further than I wanted to, but I just figured you haven't seen a difference of two square problem, so I'll show you what it's going to look like. It's not the one, so this is the only one that's not from your homework, okay? All right, so let me see if I can mimic it. M squared minus 4. Give me a second, because I'm going to have to create one here. Actually, I don't... Oh. All right, so here we go. We'll do... All right, so this is kind of similar to the one you guys have. I'm trying not to make it like too easy and also not more difficult than what you have to do. All right, so again, it's a fraction. We have expressions on top and on bottom. So we're going to look at the top first. Okay, I see a binomial. Okay, do they have anything in common? The m squared minus 4? No. Is it a difference of two squares? Yeah, right. It's a difference, and notice m is squared, and I can write 4 as 2 squared. So it is a difference of 2 squared. So let me write this out to the side. M squared minus 4. is the same as m squared minus 2 squared. So this would be m minus 2, m plus 2. Okay? So that's done. Let me write that out on my main portion. M minus 2, m plus 2 divided by, now I'm going to look at the bottom. Okay? I see 2m to the fourth minus 2m to the third. Do they have anything in common? 2m cubed. All right, so let me just write the question here really quick. So I'm going to take out a 2m cubed, and what's left is an m minus 1. Okay, because 2m to the fourth divided by 2m cubed is just m, and 2m cubed divided by 2m cubed is just 1. All right, is there anything I can do with the m minus 1? Is it a difference of 2 squares? No, right? I can't trinomial factor it because it's only 2 terms. They don't have anything in common, m minus 1. So I'm going to write 2m cubed times m minus 1. All right. Is there anything that I can chop? Like anything, like do any of the parentheses match? No. Can I get rid of, let's say, this 2 with that 2? No, right? Now, if there was a 2 right here, could I get rid of the 2's in the front?
Yeah.
Yeah, right? If the 2's hanging out by itself, sure, if it's multiplying. But it's not, so I'm done. Okay? Sometimes when you factor stuff, they don't have anything in common eventually, so you just stop. And that's it. All right? So let me go ahead and stop this here.